Hi, thanks everyone for coming. Antoine and I are really very excited to present some of this stuff to you. Hopefully you'll see things that you didn't know were in Safari, and you can start using them both on the web and in your apps if you're embedding WebKit in your apps. This session basically is building on the features that have been added to Safari since it became open source. We're focusing on the graphics-related features. While the topic of the session is vector graphics, we're actually starting with a little bit of CSS. And the reason for this is, if you look at the majority of web pages today, the really rich graphical web pages are using CSS to provide the look and feel. Now, Safari 3 has added some new CSS features based on standards that were defined a few years ago that allow people to effectively make their pages or their layout easier because they're using these new features. After that, I'll give an introduction to Canvas, which is a way to use JavaScript to draw graphics in the browser. And then Antoine will finish it up by giving an introduction to SVG and so show some nice demos. So I just want to start with something that I don't think I haven't seen highlighted too much in this conference, is this fantastic new redesign for Apple.com. And if you're a web developer, or even if you're not, you should really take a look at the site and in fact, not just look at the site as it is in the browser, view the source and have a look at the way they've implemented it. As this session is actually building on all the hard work that has been done by the WebKit team and the WebKit community, this site is just some amazing work done by the design team. Now, I'll show this next one. I assume that everyone knows, like when Steve gets up and gives a keynote, that afterwards the press and the media and the whole world and the blogging community are going to examine nearly every word he goes over and really look at what happened in detail. Well, the sort of web nerd design community have the same expectations for a company like Apple when they redesign their site. If Apple did such a sort of major redesign as this and still used technologies from 2001, they'd probably get lots of negative press. But this is just fantastic. Now you can see sort of how the look and feel is sort of similar to the previous design. But what's interesting is they've used much more semantic markup to get the effects, and this is one of the benefits of CSS. So the toolbar across the top is in fact a list, an HTML list, and CSS renders it as a toolbar and assigns the background images with a nice gradient fade and works out which images, which tab has been selected as the main tab and colors that a different background. The other things you notice is the current trend today of what I sort of think is like child-safe kitchens, where every corner's been rounded off so no one's going to hurt themselves. I actually looked through the site and I only found 2 sharp edges, and they're actually on this slide if you look closely. But I don't know whether that was just something that didn't happen or was intentionally, but I can't complain about the design in any way. Not only is it just doing layout, it's actually got some great interactive features, and it's really giving the look and feel of Apple to the people that are visiting the website. And this is really important. Here we've got very rich media, lots of content, lots of graphics. We've got some interactivity where you can slide across and see the products that Apple make. Also, with this is the second half of that page, they've got QuickTime embedded that has some interactivity to it. This section on the left here, if you mouse over it, you get these animated effects. Now, people have probably seen animation on the web for a long while, but what's new about these websites that are coming out now is the animation is done as a core part of the browser, using the features that the browser implemented. In this case, it's using JavaScript. And the other important thing is that because it's just using JavaScript, the content, the semantically rich content, has been sent to the browser. So if you don't have JavaScript or you're running on another device, or for example, you're not even running on something that has a screen, you're just having it read to you, all the content's available. A richer experience gets, if you're on a more powerful browser, you get a richer experience. This is effectively making the web or video and all these effects a core piece of the web browser technology. Now, unfortunately, as they made this beautiful site, as Apple.com has to be visible to everyone, including browsers or including users on a popular operating system that use a very popular browser, they can't necessarily use all the features of CSS that have been implemented in WebKit. So the new features I'm going to talk about now could have been used, but they weren't used. And this is actually an important thing to know about web standards. CSS, in fact, is just past its 10th birthday. But what happens with web technologies is hopefully you standardize them in some way, browsers start to implement them, they get some level of interoperability, and once it reaches a level of market penetration, then people can start using it in their content. So here's an example of how it could have been a little bit easier in the Apple redesign. So one of the most common features that people use is these rounded borders, and often you see a sort of nice gradient fade on the rectangular area. Now, the problem with that is sometimes that means you have to wrap your markup in sort of empty elements to provide sort of extra boxes that you can attach the graphics to. Well, the background image tag has been extended here to be able to take more than one image. So instead of just saying background image and give it one ping file, I've given 5 in this case. Now, another great thing to mention about this approach is that it's actually great for backwards compatibility. We're not breaking any existing content here. If an old browser hits this, your page isn't going to be unrenderable or whatever. It's actually using the features in CSS to add functionality to new versions of CSS. Underneath here, I set a background position for every one of the images, and that's a pretty ugly graphic. But what will happen is that paragraph would resize to whatever text is placed in it, and the graphics would align themselves with the way I position them. Another similar property is the ability to set one border image and have it resized to fit the entire content. And this is, again, implemented in Safari 3 and been in WebKit Nightly for a while now. So here, again, very similar to the way it's actually done at the moment. You said border image property, which takes a parameter URL to a PNG file. And here's the extra bit, was where I set some 4 parameters after the image to specify how it's sliced up. And I'll show you that in the next slide. In this case, I did add another semantic element here, a div around the paragraph. What that means is that no matter what content I had placed into that div, the border is going to resize to whatever size the content is taken. So let's have a look at how it's done. The actual border image can be any size you want. So I mean, here, the actual image that's used to render that border is a square. But if I go back one, you can see it's been resized to fit the shape of the content. Now, with the 4 parameters here, I'm specifying basically 4 slices that will generate 9 individual pieces of the image. And you've got the 4 corners will go to the 4 corners of the rectangular area in CSS, and the middle pieces middle edges and the middle of the element itself get resized to fill the space. Now, that's all I was going to talk about in CSS. Now I'm going to go on to doing Canvas. Just before I leave CSS, I didn't want to talk about the thousands of features that use CSS. I'm instead going to do the web way and say, go to apple.com and view source, and you can get all the tricky ways that I've implemented things so far. So now let's talk about Canvas. This is something that is quite cool. Of course, again, people have seen graphics in the browser and animations in the browser, but in this case, this functionality is exposed directly to the engine itself. You don't have to call any external plugins or whatever. So Canvas is an HTML element, and the HTML element defines a rectangular region of the page, and then also a JavaScript API that allows you to do whatever you want with that rectangular image. It's been available since Safari 2.0, which means you can already use it today on Tiger. There has been some slight updates to the interface since then. It's been documented in a standards process, and they've made some slight tweaks. So you should, if you're using Canvas, you should check your dashboard widget or whatever it is on Safari 3. Another interesting thing about it is what I say is draw and forget, is that Canvas just updates pixels in the page. If I draw something on it, I don't actually have any memory of the fact that I've drawn it. What's happened is that the actual page has been updated to whatever I've actually sent to the screen. This is kind of different to the way typical web programming happens, where you have the object model of the document there, and you use the JavaScript to examine the document and provide some kind of effect based on what the content is. In this case, it's purely for just rendering images or rendering pixels on the screen. The advantage of this is it has a very low memory footprint. If you've got to display thousands and thousands of objects, you don't want to have a DOM element for every one of those. You just draw to the screen using JavaScript, or generate the graphics using a program. This means it's quite high performant, and furthermore, it's actually a very simple API. Now, I'm a pretty simple person, so I like simple APIs. Again, it's the way the web works, is you don't necessarily have to deliver everything to the users straight away. You give something easy and you can build on that as interoperability arrives. Actually, just before that, of course, you may know Canvas from such dashboard widgets as the clock, where it's used to rotate the hands, and the fantastic flight path widget, where it animates the path of the plane, which of course would be sort of impractical to store on the disk or on the server. The thousands of images that would be required to show every path. So where is it available? Well, it was again invented by Safari and shipped with Dashboard and Safari 2.0 and Dashboard. Since then, Firefox and Opera have implemented it interoperably. It's also available in IE because people have used a JavaScript library that effectively mirrors the API and then calls some features that are only implemented on Windows IE to draw the same graphics. So it is something you can use everywhere with a little bit of work. From now on, its development has been sent to the standards bodies, first to the WhatWG, which included in HTML5 specification, and that specification now is part of the W3C HTML working group. So hopefully what we'll see is, again, complete interoperability, as well as some new features coming to later versions of HTML. For the core graphics programmers out there, the API will be very, very, very familiar. It's got paths, strokes, fills, gradients. I'll just mention a few things that maybe web developers are more interested in. Other than that is you can do the shadows automatically. Drop shadows, they're so 2006 now, but maybe they're still used. Patterns. For the core graphics programmers, there's one major difference is where in core graphics you get a drawing context and you pass it into the functions you call. In this case, you get the context and call methods on the context and set attributes. It's the same idea, but just slightly different way of approach. So how do I include it in a web page? Here's a typical web page. I just have a canvas element. I give it a width and a height, and that basically reserves this part of the screen, the blue section in the page, that reserves that part of the screen and allows me to draw into it using JavaScript. How do you actually draw? Well, like regular DOM programming, you use getElementById in this case, I've given the canvas the canvas element an ID canvas. That gives me a reference to the DOM object that implements the canvas. And then I ask the canvas for the drawing context. And the drawing context is a thing that's actually associated with each individual canvas on the page and allows you to render graphics into the canvas. Now, it's probably worth noting that you can see I pass a parameter into the getContext call, which says 2D. The reason for this is it's designed to be extensible. You're just given basically a blank region of screen or a blank canvas. There's no reason why you couldn't have 3D graphics in there or any other type of graphics you could possibly imagine, or even simpler or harder. The idea is that whatever is returned from the getContext call is going to give you something that renders into that region of the screen. Now, in this case, I'm calling 2D because that's the only one that's implemented, but you could hopefully imagine that maybe later down the track you'll be able to ask for a 3D context and again render 3D graphics. Once you've got a context, you set attributes on that object, and those attributes control the method of drawing, whether it's stroked with a particular color or width or height or opacity. And then you call methods on the context object to actually render shapes onto the page. A quick mention here about what it means to have vectors. Because the vectors are described by a mathematical function here, it gives you an easy way to have resolution independence. The canvas, while it's given it's given its width and height in terms of the page dimensions, that doesn't necessarily mean that you can't use a coordinate system and basically map the model of the graphics that you're using into the Canvas system by setting transforms. So the Quartz 2D people should be aware here that Canvas uses a Y-down coordinate system, which is probably the opposite to the way most people learnt geometry. The reason for this is that, the reason it's different from the typical Y-up coordinate system is that, unfortunately, that's the way that HTML sort of works. As you add elements to the page, the content moves down the page. And this sort of effectively makes it easier for people that are familiar with CSS that uses this similar approach to move into using Canvas. And of course, once I have a coordinate system, I can do whatever I want with it. I can translate it. And it's not just moving it around. Again, I can also say rotate the canvas. I'm not rotating the canvas itself, rotate the graphics that I'm going to draw in the canvas. In this case, squish them in the X direction and stretch them in height or Y direction. So let's just do a very simple flow through of what happens. So imagine this is the canvas. Now you're actually given a blank canvas to start off with. So I mean, I'm just using the grid to show what's going on. Now I call this very simple function fillRect, which is saying use an X position and a Y position of 100 and a width and height of 200 and 300, and it's just got to draw a rectangle on the screen. We'll go into this in a little bit more detail later as to actually what's happening here. And you can see, again, the Y coordinate system goes down the page. So once you've drawn on the canvas, you've got no knowledge. I mean, you can't decide, you can't examine it to see what's actually on there as such yet. So if you're going to draw multiple things on there, they're just going to start piling on top of each other and obscuring it. So usually the first thing you do is say, I want to clear the canvas, which is basically just going to wipe the graphics out and give you a fully transparent bitmap. So if I call this clearRect function, in this case I'm calling it on the entire canvas to remove everything, and I'm starting back with a completely empty screen. Now, the way that fillRect actually was implemented, or I don't know if it was implemented this way, the way you should understand that it's behaving is the context of paths. It's again, same to the way that even Quartz 2D has paths and also the Cocoa layer has paths. You start by saying a begin path, and then you give it a set of functions, and you have this knowledge of what the current point is. So I begin a path, and the first thing I'm going to do is say move the current point to 100, 100. Then I say to it, move the current point to, draw a line to this particular point, and I'm going to go down a bit, then I'm going to go along a bit. And finally, I'm going to say, now from wherever you are, go back to where we started from, and that's going to give you a complete filled path, sorry, a complete object. And then the next thing I do is actually call a drawing operation on that, which is fill, and it uses the path and renders, in this case, whatever the current color is into the path. Now, of course, I don't have to have just rectangles. I can here dazzle you with my artistic ability and show you that any curve or shape that can be represented by Beziers or arcs or whatever can be added to the path. And again, you just close the path and fill it, and it's got to use whatever the current path is. So how do you set the actual attributes of drawing? In this case, I set the fill style to be red. You can pass in a color value in CSS. And I fill a rectangle. Now, once that's done, I have to update the fill style here to green, and I draw the rectangle in a slightly different position. You can see that it's obscured the red one. In this case, I'm setting the color to blue, and I give what I'm saying here is the global alpha, which means that every drawing operation that happens now is going to be 50% transparent. So you can see how this blue rectangle has parts of the green rectangle showing through it because it's semi-transparent. Stroking, again, very, very simple. You set the stroke style. I've set the color to be red. I give it a line width. And what it's done is traced the path with a line that's 5 units wide, and you've got a stroke. Now, you can control the order in which this happens. So if you wanted to draw a stroked rectangle, for example, you can decide, in this case, to set the color to blue and fill it. Then you set the color to be green and stroke the same rectangle. Now, this is sort of the typical way things work. You expect the stroke. The stroke actually is aligned on the middle of the path. So you've got half of the stroke is on one side and half of the stroke is on the other side. So the order matters here. You would get a different effect if you did the fill the other way around. Draw images, and they're very, very simple here. I just set an X and Y point. Well, I should actually say, the way you actually reference an image is kind of interesting. In this case, the HTML document itself, I've put in an IMG, an image tag, and I've referenced a particular URL. And then in my JavaScript, I use getElementById to get a reference to that image object. And then I can draw it in the canvas. You can also use JavaScript to create a new image object, and you pass in a URL, and it'll fetch the image for you. Then I tell it to draw on the screen at an XY location, and it's going to use the default resolution of the image to draw the screen. Now, it's also interesting to note that the image here appears the right way up. So there's some things like text where you can't draw text, but you have to realize that the coordinate system doesn't always necessarily work the way you want it to work. I can also pass a width and a height to draw the image in. In this case, it's stretched the rectangle in the horizontal direction and squished it. Now, that's one way to squish and stretch an image, but we could have also done it through transformation. So in this case, I'm going to draw the same rectangle a few times. The first thing I've done is translated the coordinate system down by 100 units in the x direction and 100 units in the y direction, and then drawn a rectangle. And as far as the context knows at that point where I'm drawing the rectangle, the whole coordinate system is shifted, and I'm just going to use whatever I'm in at the time to draw the rectangle. So now if I, again, translate the coordinate system a bit further down, I'm also going to apply a scale, which means that from now on, while I'm using my same model coordinate system, when I render the screen, all the x values have been stretched by 2. So what was a square is now, 100 by 100 square is now a rectangle. And you can go further than that. In fact, you can then rotate the coordinate system. And these transformations, every one you apply, it sort of adds the transformation to a stack, and you get a new coordinate system. And you can reset the transformation, or the transforms to go back to usual. And one way to do this, or one good approach, is that the context has the notion of a stack of states. So, for example, you're in a function, you want to call another function that may do some transforms, but you want to, when the function exits, you want to get back to the state you were before. What you do is, in fact, save the state on a stack, call the function, and everything you do to the fill style, the stroking, and all the drawing attributes apply to the current context. But once I call the restore state, I pop whatever the save stack is off the save context is off the stack, and I'm back to where I was. Actually, at this point, I'll go do a demo. I thought there was a slide that says demo here. Just give you an example of what can be done. So in the Graphics and Media State of the Union, Darren Adler from the WebKit team and Safari team got up and said, Canvas, here's a way to do Canvas to do the current trend of reflected images. Let's just have a quick look at how this was done. So here I've got a reference to the canvas object, got a reference to the context, and I basically just draw an image. Grass is the name of the image I've got from the document. That's going to put the main image on the screen, and now I do some transformations on that. I'm going to flip the coordinate system so that the reflection actually happens as if it looks like the physical world would. And I also decide to set a bit of alpha so it's not completely opaque. And then I draw a gradient color over the top of it so that it fades into the background. So you can see, basically, here's a rectangle, and by the time it gets to there, it's being drawn as if it's the background color. Now, what are the type of uses of Canvas? The thing is, because you're actually just rendering to the canvas, you're not necessarily putting any content in the document. It means while Canvas is incredibly useful, you've got to be careful in the way that you actually use it on a page. So, I mean, I was just sort of thinking, well, what happens if you had a surf shop and you wanted to, say, represent the current swell or whatever to the customers that were viewing the page? And what's kind of interesting about this is that it's an effect that people will see, but if they didn't have support for Canvas, or if they're running on a device that doesn't have the interactivity, they're not going to actually necessarily lose any content. They're still getting the same data. Some people are just getting possibly a better experience, although this demo isn't so fantastic that I would call it a better experience. Now, Canvas can be interactive in the same way that every regular HTML element is. I can attach event listeners to it. So, I mean, here I'll click on it. You know, I'm a demolition company, and I'm going old school, and I wanted a splash screen that enters into my site, and there's some cool bricks that manage to hover in the air for a long time. But again, that just gives you an example of the kind of, you know, it's quite a fast and well-performed API that you can use. In fact, people have implemented 3D renderers, ray tracers, or fake sort of 3D engines using Canvas, or even games. I've seen Lemmings replicated in Canvas. And again, you can have these interactive elements that do things. You see opacity there. I can click and again, just getting the current position on the screen where the mouse is over, and drawing a circle and moving the mouse around. I'll go back to the slide. Thanks. So what you should keep in mind when using something like Canvas is that you have to make sure that your content is accessible. So as I was mentioning, you shouldn't rely on the fact that people are going to see whatever you draw on the canvas to effectively get to the content or interact with your site. It's purely for giving effects or adding something more to the page. Also, this is something that the Web Accessibility Guidelines say, is that you should always use animations wisely, and there's a number of reasons for that. Some people, it can actually be very distracting to them to have lots of movement on a page. Another good reason is that if you've got an animation running that's just for the sake of making your page look cool, you realize that, you know, that thing's, you know, hitting the CPU. It might not be doing much, but if it's animating fast enough, it's, you know, something the CPU has to wake up for every time. And if you're on a resource-limited device, for example, that might mean that the battery can't. I mean, they can't go into low power mode quickly. So it's important for sort of mobile devices. So that's all I had on. Oh, there was the demo slide. There we go. That's all I had on Canvas. So now I'm pleased to invite my BFF, which is best French friend, Antoine Kahn, up to the stage. He's going to talk about SVG. Shake and bake. Oh, sorry.
Thanks, Dean. So we're going to continue in the trends of exploring the various graphics capabilities that are available to you in Safari 3. And here we're really entering a world of feature that is completely new to Safari 3 that were never supported before in Safari 2 or previous versions. Of course, they've been available to eager developers for a little while who were downloading nightly builds of WebKit, and et cetera. But this is the first time that Safari users will be able to leverage those features when creating content and hosting WebKit within their application. A quick introduction to SVG. SVG, just like HTML and CSS and a host of web standards that people have grown to love or despise, but yet use on the web, is a W3C specification. It is a full web standard designed as such. Currently, the version of SVG that we will find implemented in browsers is SVG 1.1, which really defines a set of features for creating rich graphics specifically designed for the World Wide Web. Looking forward, in a couple of years, as Dean highlighted, it takes a while for technologies, web standards to really get properly supported in web browsers and reach a mass market. The next version of SVG is already underway. It's called SVG 1.2, and it will go more deeply in the world of rich media and animations and interactivity. So the design goals of SVG, when it was developed within the W3C, was to really provide flexible technology for creating graphics that will be scalable, which is very important when you're dealing with various sizes of screens and resolutions and et cetera, but would also be rich graphics, interactive, and animated. And of course, we're only dealing here with two-dimensional graphics. There is nothing in SVG that will really help you towards creating 3D worlds or anything like that. Another great design goal is that were SVG to succeed on the web, it would have to integrate properly with other web technologies. And integrating with XML, HTML, CSS, the DOM, JavaScript, PNG, and all other web standards they're using every day when designing web applications and websites have to be adequate. SVG has to be adequate and integrate nicely with those features. And Dean highlighted how important view source is when you're a web developer and you want to learn new techniques and etc. And certainly SVG is no different to that. You're dealing with a markup language, and you can open any SVG graphics on the web and view the source and learn how it was created directly, which I think personally is a way I learned a lot of my web design skills. Currently, so Safari 3 supports SVG as a new feature. Other browsers on the market support SVG as well. Firefox and Opera do support SVG, and a similar set of features such as shapes and paths, support for text, solid colors and gradients, stroked outlines, opacity, fine transforms, and etc. But also scripting and scripted animations. But we will get into that later when we get into the more technical part of the presentation. The way SVG is being used today on the web, it's still a very up-and-coming technology, and this is due to browsers only starting to support this technology recently, but I think there are already good, interesting signs on the web of people picking this technology up, and certainly the whole mindset currently around Web 2.0, which is very pragmatic and whatever means I'll have to employ to meet my end is what really doesn't really matter. I just need to do what I need to do. And SVG can be leveraged very well for the people who just want to get things done directly. So of course, as an open standard, it was directly picked up in the open source world. And as a document format, it's really well suited for dynamic generation on the server, just like you would generate HTML dynamically. So you will find a few graphics packagings and mapping systems built around PHP, Perl, or Java. But SVG is also, of course, a client-side technology. And JavaScript libraries are getting more popular every day. There's a few mentioned in this very track at WWDC. And a few of those libraries, such as Dojo, TIBCO, and Google Web Toolkit, also using SVG as an abstraction as a backend rendering for their JavaScript APIs to do 2D graphics. So this is also a way that you can actually start using SVG, even though you might not use the language itself. It is powered, everything that you'll do with these APIs will be powered by SVG. And actually, to look at some well-known applications that have already started to use SVG, just to note a few, Google Maps and Windows Live Local both support SVG to draw overlays, your little routes over the map of mostly raster data. And an interesting product that's just been acquired by Google, it's called Tonic Point, is really a sort of PowerPoint kind of authoring tool on the web, Web 2.0 application. But SVG goes beyond the web. As a standard, it can be applied to any sort of space that people are interested in applying it. Certainly, as a graphics technology and as a document format, it is important that there's graphics authoring tools out there for you to use, and especially for designers who are not really expected to code, markup, and scripting. And a few tools that I'd like to mention here is, of course, Adobe Illustrator, which is the industry standard tool, has been supporting SVG for years now. Lineform, which is a macOS 10 tool that won the Apple Design Award last year, is another tool that supports SVG. And in the open source world, Inkscape is a tool, a cross-platform tool that supports SVG. It's a vector drawing package. But there are many, many more tools from the CAD world to the mapping world and etc. These are mostly creative graphics tools, but lots of industries have already started to rely on SVG for content creation. But in terms of the in terms of desktop usage, SVG is already used also within the KDE and GNOME user interfaces to render all the icons that will be rendered on screen. Of course, SVG being a vector graphics format, it is really handy. It is very handy to define your icons using that format, because that means your icon will be able to scale to whatever the user preference will be set to. So if you want small or rich, great big icons, you will still get the same level of details all rendered by SVG. And moving into the web/desktop application space, hybrid apps, which is another topic that's covered at WWDC this year. A TV application that's launching currently called Juiced actually chose to use web technologies, and more specifically SVG, to create its whole user interface. And what's interesting about Juiced is that the whole user interface is scalable, so that when you use it on a TV, which might be 16:9 or in HD, Full HD, etc., or a computer, or any kind of resolution and screen aspect ratio, the UI will scale and behave nicely regardless of your display settings. So this is a few of the things, a couple of screenshots of the application. You can see everything here is basically rendered using SVG. So put back SVG into the context of web development. First of all, I think what is really tremendously great about SVG is that when you use SVG, even though it might be a new technology to you, you are not entering a foreign territory. You are likely going to have a whole lot of skills that you will be able to directly apply to SVG. So a few of the main points about SVG, and to meet those design goals I mentioned earlier, SVG uses an XML grammar. Everything is basically markup. So when you draw things, you basically have elements in your document that define how things need to be rendered on the screen. And just like in HTML, when you can use JavaScript and the DOM to manipulate your content, the same concept can be applied directly to SVG. CSS, of course, is also usable on SVG. And finally, what I think is very important about SVG is that it can be as a web standard, it can be and is, of course, implemented natively by browsers. So what it really means in practice is that now you can author content using the same principles like HTML and CSS. You know about markup, you know about structuring your markup, you know about semantics around markup, you know how to apply CSS and selectors, etc. And these exact same things you will be able to apply to when creating SVG content and developing with SVG content. What's really interesting, of course, because of the markup and the fact that it's an open standard, is that it is integrated right into your web page. You're not using a plugin architecture and just rendering something on the side in a black box. It is a first-class citizen within your web page or your web application. And when it comes to scripting, well, then all the skill set you've starting to build up around Ajax is going to be applied directly also to SVG. You'll be using the same programming language, which is JavaScript, and the same programming APIs, which is the DOM. So all you really need to know, if I may say so, is to know about SVG specifics and to learn about how you can create graphics using SVG. But before we delve into that, I just wanted to say a few things more related to the Mac. SVG was not designed for the Mac or for any platform in particular, for that matter. But I think it's worth understanding that SVG really feels like a Mac-type technology. The way SVG is implemented, for example, in the WebKit rendering engine in Safari, is using the Quad Studio graphics command. So Dean showed in Canvas how commands would be mapped very acute between Quad Studio and Canvas, while SVG, in a way, is a very higher level of abstraction across those very rich drawing APIs. And of course, since everything in SVG is based on vectors, you get, by default, resolution independence as a feature. So when you're dealing with new types of user interfaces, this is really something that will be tremendously useful. All you need to do is change some of the properties of your SVG document, but the scaling will be done automatically. So comparing SVG to some other proprietary type of technologies that are cropping up today or have been around the web for a long time now, well, the core difference, of course, is that SVG is a royalty-free standard developed by the W3C. It is open. You can participate as a developer if you're interested. And of course, it lends itself very well to open source implementations. And a direct benefit of the fact that it's an open royalty-free standard is that the standard does not belong to anyone. It is vendor neutral, and it's not up to a single company to define where this technology will be going. So as a user or as a member of a corporation, you can join the W3C, for example, and join the effort of defining the next steps of the SVG standard. But another great benefit is that instead of dealing with a single implementation and possibly a company that would rest on its laurels or stop listening its customers because they have a strategy they want to impose on their users, well, we're dealing here with a technology that will be implemented by many implementations, and certainly Safari, Firefox, and Opera are a great example of this. And these people will be competing to provide the best experience. So we saw that on the web, when Internet Explorer was a great dominant force on the web and slowed development for years, it's really slowed down the innovation on the web. And only when new wave of browsers such as Safari cropped up, then the Web 2.0 wave happened, and it opened up a great new world of possibilities. So I think this is a tremendous advantage of SVG. But of course, like I said, SVG is standards-based. It's based on markup, it's CSS and JavaScript. And so you will be able to use it at the same level as a first-class citizen as these technologies. You're not dealing with a plugin. And not dealing with a plugin means that instead of dealing with a black box that's rendered on your screen, you're really dealing with something that shares the same rendering model as HTML and CSS. So if you really want to do precise, intricate compositions, you will have all the flexibility that you will need using SVG and other web standards. Directly related to this, having a mockup and a shared tree means that the same eventing models will be used across your HTML and SVG content. Whereas if you're dealing with a proprietary technology, they will probably have a different eventing model, and certainly something that will be more local to the little black box in which they render inside the plugin. And another aspect of this shared DOM tree is that you will be using the same APIs and the same scripting environment to develop your SVG content and implement interactivity and animation. And we'll see some example of that later on. But when you're dealing with plugins and proprietary technologies, then you will certainly have to use either a different language or a different iteration of a language, and certainly a different set of APIs. So I guess what I really mean to say here is that SVG really belongs on the web, just like HTML and CSS have been developed. This is really something that should be familiar to anyone who has skills in this area. So Dean went through the Canvas feature set earlier, and of course these are two technologies that share that have things in common. So it is, well, mostly that they are used to create 2D rich graphics. But they are, however, quite different, so it's worth trying to isolate some use cases in which technology might be more appropriate. Of course, your mileage may vary, and depending on your skill set, if you're more interested in direct programming using lower level APIs or higher level markup, then you will definitely make your own choice. But for those few use cases, for example, if you're doing with a static image, basically a static graphics asset that you would want to use to load dynamically in your document, or you want to save an image in SVG, well, SVG is a document format, so it is really meant to be used in that way, whereas Canvas is a series of programmatic operations, so it does not really, is not really contained inside a format or anything. So if you're creating just static images, then SVG is probably a better choice. When you're dealing with huge number of objects, Dean highlighted how Canvas is a way to just draw and forget. So there's no huge memory footprint attached to using Canvas. So in this case, if you need really performance and don't really care about preserving a state of objects, etc., then Canvas is probably a safer bet. But when we're dealing with interactivity, then SVG really shines because exactly because Canvas draws and forgets, you do not have a concept of objects or structure that you will be dealing with. And whereas SVG always has anything that's drawn on screen as a direct live representation in your DOM tree. So when you need to do interactivity, you can simply get a handle to one object and update that object, whereas in Canvas, you would have to re-render the whole canvas to change the state of your graphics. Same goes for animation, basically. Since if you want to do a discrete animation on one object of your tree, well, in SVG, this is simple. You can just get a handle to that rectangle, change its width over time. Whereas in Canvas, once again, you would have to compute the animation and the rest of the graphics to re-render every time. And of course, if you don't really care about a data model and just want to draw something and forget about it and just display it, let it sit there, then Canvas is probably also going to be, in that case, a better choice because, well, what's the point of having too many bells and whistles when all you want is to display a bunch of pixels on the screen? And finally, when you're dealing with server-generated content, then obviously SVG is a smarter choice because it is XML. There are millions of tools out there on the server side to deal with XML content or even graphing packages, mapping, et cetera, like I mentioned earlier. So basically, document format is always going to be more appropriate for creating content on the server. So let's get started into the more technical part of SVG. We won't get in depth because God knows SVG is feature rich and it takes a little while to really work out its little intricate details. But we'll still, however, try to cover the main bases. First of all, before drawing anything with SVG, you need to understand how you can integrate SVG in your web page. You have several scenarios as to how you want to go around doing it. First scenario is by using a reference to your SVG document. So just like in HTML, you can use an iframe to load an external HTML document. You can use object, embed, or iframe to point to an external SVG document. However, if you're dealing with more of a scripted environment or you want the optimal flexibility, then you will probably want to mix the markup, HTML and SVG, into a single document. So in that case, you will have to contain all your SVG graphics within an SVG element within the SVG namespace. Of course, you don't even have to have any markup already sitting there to create SVG graphics on the fly. Using script, you can directly use the DOM to add any new SVG assets to your document using the DOM. So just to look at pros and cons of either techniques, reference and inclusion, using a reference inclusion will mean that if you're dealing with maybe a widget, like a stock widget that you would just want to display on your web page, but it's not really part of the content, it's just something you want to have sitting there as an add-on, then you're dealing with an external asset, and it's probably better to just point to a URI and let it be and not bother the rest of your document to deal with this. But however, using that technique, if you want to get inside that content and update it and integrate it with the rest of your web page, then you will have to use specific DOM accessors to get to the SVG document. In that case, it is the content document property that you'll be able to access on the object or embed element. Whereas when you're using inclusion, you're dealing with a mixed namespace DOM tree, which is also a single DOM tree. And that means that you have complete flexibility as to how you want to structure your content. This also means that you have a shared DOM and CSS tree. So you can apply styling with a unique style sheets to both SVG and HTML content, which is really, really practical. So it's really about if you're dealing with external assets that you just want to bring in there, or if you want something very flexible and to have a unique document to represent both your textual data and et cetera in HTML and more graphics in SVG. So obviously at that point, using a mixed document, it will be tougher to manage external resources. So SVG has pretty much all the graphics features that you would expect from a modern graphics language. Vector shapes, obviously it's a vector language, so these are the core, Bezier curves, and etc. Of course, you can also have solid colors, but also gradients and patterns, fill opacity, etc. These are all features that we're going to go through by example right now. And the second set of features that we'll go around later on is how you can use the DOM to add interactivity to SVG. And this is really where SVG shines and is unique, is leveraging the concept of markup and scripting together to create really interactive graphics and even animated graphics. So to start things softly, the first thing, the equivalent of hello world in the graphics world is to draw a rectangle. So whereas in Canvas, of course, you would use a set of APIs to basically do the same thing. In here, you're just using a declarative markup approach. So you have a rectangle drawn with a rect element, set its graphic properties using the XML attributes X, Y, and width and height. And it doesn't really take a genius to work out what's going to happen here. Of course, rounded rectangle are also supported. You just have to use the RX and RY attributes to define the corner radius in the X and Y axis for your rectangle. Circles are represented by their own elements as well. The CX and CY will define the center of your element, and the R attribute will define the radius. Ellipses are pretty similar, except you will have both an RX and RY set of radiuses to deal with the X-axis and Y-axis radius. Polygon is another element where you can give it a set of points, and I think something that's worth mentioning here is that even though SVG is an XML language, all of its features are not directly exposed as XML. So in that case, the list of points, which is a flat structure, is just a micro syntax within an attribute. So you could have thought that we would have a set of elements as child of polygon to specify points, but that's not the way SVG is designed. And I actually don't think it makes a lot of sense because XML is really good for a hierarchy, something that has an order that you might want to reorder, whereas this is really a flat list of coordinates. Path, of course, you need to have optimal flexibility when dealing with graphics on the web. And here again, we have a micro syntax with different comments, such as M for move to, C for curves, and there are lots of other sets of comments. You can use a path, for example, to draw the Apple logo. And of course, when you draw things, you need to bring color into the equation to have something render on the screen. And so instead of having, like in Canvas, a context of here's what I'm doing now, I'm using a red color to fill and stroke and et cetera, here we just have per object properties to define what color they are. So you can use the fill attribute to define what the fill color is, the stroke attribute to define the stroking. Fill and stroke are all on the same object, which is actually quite handy. You don't have to use two separate things to draw a fill and a stroke. And you can use all sorts of values for these fill and stroke attributes. So you can use keywords such as blue, an RGB combination, RGBA actually also if you want to have transparency directly expressed in your fill or stroke color, hexadecimal, etc. All these the same data types that you would use in HTML and CSS. You can also control fill and stroke opacity separately from one another, or use an opacity attribute to compose the whole graphics together against the background. Of course, we can get into more advanced paint servers, such as linear gradient. Once again, nothing very surprising here. We define a linear gradient element, give it an ID so we can use it later on to define an object that will use that as a fill. And you use the xy, y1, x2, y2 attributes to define the direction of the gradient. In that case, we have a gradient that's going to go from the top, well, anyway, you figure it out. To use that linear gradient, you just use a URL construct within your fill. So that means you can create a set of resources of paint servers that can be used by different assets in your document. So you can have 5 different rectangles using the same gradient, and if that gradient changes or is animated, then the different objects that use that gradient will automatically be kept in sync, which is really handy. Radial gradient, of course, pretty much the same way. You also define a center for the gradient and a radius. You can have, of course, multiple stops. Here, there's only a first and a last stop, go from 0 to 1, but you can have as many stops as you want with how many colors as you want. And of course, you can also set up, even though it's not illustrated here, a stop opacity for each stop, so you can have nice little drop shadows that will fade in gradually. Clipping, another very important features in graphics. So a clip path is a shared resource. You can use any SVG element as a child to define your clip path, so it doesn't have to be a rectangle, rounded rectangle. It could be anything. It could be very free form. It could be a path, for example. In this case, we're using an ellipse. And we apply the clip path of the ellipse to a rectangle by using, once again, the URL construct applied to the clip path attribute. And you can see the rendered area here in between the stroked lines with the solid fills of blue and the stroke of red. And there are, of course, way more features. I mentioned here we haven't used any CSS. We have only used direct XML attributes. But in this case, we're just demonstrating how we can use the same attributes as properties. So we have fill and stroke with properties, which are new to CSS for SVG usage. And you can create a class, for example, the Mr. F class here, which we'll be able to reuse across different graphics later on by using the class attribute. You can also define styles inline on your element using the style element, if that's what you're into, just like you would in HTML. You can draw text very easily by giving it an anchor. The baseline will be the lower part of the text that will be aligned with this position, and just have your text right here. So this is really handy because not only you can draw text, but you can transform text just like any other part of SVG. So in this case, we rotate our text by 45 degrees. Like I said earlier, we can use a class attribute to define the look and feel of our rectangle. So in this case, we're using the Mr. F class that we used earlier. And another great feature of SVG is that as long as you define an element with an ID, you will be able to reuse that element in any other part of your document without having to replicate it in the DOM tree just by using the use element. So in this case, we have the Apple logo as a path, which shows in white at the lower end of the screen. And we're going to use it once more with a transform to scale it and rotate it a little bit, apply a class using CSS. And in this case, we're using the xlinkhref attribute to point to that logo. So this is really handy when you're dealing with symbols and et cetera in your content. So what's really interesting, and I'm not going to spend a lot of time here because, well, first of all, time is running out, but also because as developers, I think these type of things will be very handy for you to pick up. And like I said, SVG is only using the DOM. So all the knowledge you know about HTML, scripting HTML, is directly applied to SVG. So if you need a handle to an SVG element, you just use the getElementById method and pass an ID that you will have set in your markup as well, and you will get a DOM object pointing to that piece of markup. You can get elements by tag names, of course. So if you want to get the list of rectangles in your document, set the namespace to be the SVG namespace, and rect to be the name of the elements, and you will get a list of all the rectangles in your document. Of course, you can create SVG content on the fly, just like you can create HTML content on the fly. You will use the createElement method in that case. Just give it the SVG namespace, the name of the element you're going to create. And once you have done that, you will want to set its core attributes. So if you want to draw a rectangle, for example, createElementNS, SVG namespace, and the rect string to create the rect element. And once you have a handle to that element, use the setAttribute method to set the x, y, width, and height, and etc. So you can do all of this dynamically on the fly within the client. And you will use the appendChild and removeChild methods to move content around and put it in the right place in your document. So I won't go in great detail about this because this is all sorts of things that you will find greatly documented out there, and everyone uses it to program web content. But what's interesting about SVG is that because it's a graphics technology, and all of these preceding methods I mentioned were all about dealing with an XML structure, SVG really needed something to be able to deal with graphics directly. So the first few things that you will have in SVG and the SVG DOM is you will have a set of data types that you can use in the graphics context. So SVG point to represent a point, SVG rect for rectangle, SVG matrix for metrics, etc. Those data types are used, you will encounter them when you start using methods such as getBbox to query the bounding box of an element, which might be complex and not directly replicated in the markup. So if you deal with a path, essentially if you want to have the bounding box and only had the XML data to figure that out, you would essentially have to redraw the path yourself logically. So the DOM in SVG will allow special methods to do that directly. So getBbox will return an SVG rect object with the metrics wherever the element is in your tree, if it's a group of elements, and etc. You can also query the transformation matrix applied to an element in respect to another element using the getTransformToElement, and get the complete transformation matrix all the way up to the client user space using the getScreenCDM method. These methods will return a matrix. And you can use this matrix, for example, to take the client text and client Y properties of an event and transform them to get into the user space of the current SVG object that you're dealing with. So this is really handy. And of course, SVG DOM also has a set of APIs to deal with those micro-syntheses that I talked about. So path structure, list of points, and etc. So you can expect that as an essential toolkit. So like I said, SVG is really great for interactive content. Interactivity is all about reacting to user interface events. And in HTML, you will use all of the same types of techniques, and in SVG, you can directly use them as well. So if you want to, it's not scripting per se, but if you want to apply a behavioral change, for example, a mouse over, or when an element is focused, you can use the CSS pseudo classes hover and focus to change the styling properties of an SVG element. Of course, you can also use markup-based handlers such as onClick and onMouse move to call a special piece of JavaScript, which is really good when if you're dealing with predefined event handlers. And you can add event handlers programmatically as you are creating your content. You can also add listeners directly from JavaScript using the addEventListener methods, which is great for dynamically adding event handlers. And animation is basically performed by using those same methods in the DOM recursively. So in this case, for example, I'm using the setInterval function from JavaScript that will call another function repeatedly given a specific interval. And in this case, I will want to fade an element from opacity 1 to opacity 0. I check the start time by getting the time from a new date object, set the duration to be 2 seconds, 2000 milliseconds, iterate through that time, figure out the offsets, and apply basically that value as the opacity. So using this function, this gives you a way to animate the opacity of an element across 2 seconds. So let's get to the most interesting part of the session, which is, of course, demonstrations. Switching to demo screens, thanks. So I have 3 little demos that are actually pretty simple, I think. So this first demo probably doesn't look interesting at all. I mean, I'm just here. It's probably just one of those new HTML5 elements, which is the input type search, which was an Apple invention. Instead of just using that element directly, I chose, because I like that kind of stuff, to implement it myself using SVG. So you can rescale it. And I guess this is really smooth when you're dealing with a need for scalable UI. If you have a really high DPI screen, and certainly those new 17-inch MacBook Pros have very high DPI, well, it would be pretty nice to be using SVG to draw your UI elements. So the funky thing here is that actually this part here is HTML. So I can type whatever I want here. It's just an input element. And the way I draw it is that I have a rectangle here in the background that you do not see in SVG, and I query its metrics dynamically every time I want to redraw, because the scaling is defined by the markup. And so this is really, really handy. And of course, I can create my own focus ring using gradient, and it's pretty neat. Another interesting demo. There you go. I co-run a website called sg.org, community website, and I have a Google Analytics account. Google Analytics provides XML feeds of the content for your statistics. And I'm just loading them up in this little piece of SVG. So this is a standalone SVG document, no HTML in this one. So you can see it scales. This is all created from AJAX calls, XML HTTP requests. So I make it a little bit wide. You can see that the little points give me I can get the data for a given date. Everything is generically done on the fly. I can change the month, go back in time, animate it, all using SVG scripting. And of course, it wouldn't be a demo at WWDC if you couldn't run it in slow-mo. So there you go. So for example, the text up there is rotated, and opacity is applied, so it transforms, the points move to the new directions, etc. So this is actually pretty simple and pretty effective, and whatever the scaling is, everything will be done regardless of the resolution or anything. So I really like that stuff. So for example, launch an animation and resize everything. It will all be done automatically. You don't have to worry about taking care of rescaling anything. And finally, another interesting demonstration that I wanted to make is when you really pull together HTML, CSS, SVG all in one big document, and to create some pretty compelling user interfaces. So this is, of course, all running in Safari 3. So this is a blank canvas. I'm loading my delicious library XML database on the fly, performing XPath queries. I search it. So in this case, I'll be looking for, I can look for different things. In this case, I'll be looking for artist name that may contain the string WI. You can see a list of objects coming up. I can have, so all of this here is SVG objects within divs that are directly laid out using CSS contracts of inline blocks. Here, this is HTML text, but the background is an SVG piece of graphics that scale automatically. I have a little drop shadow applied directly to my SVG rectangle so that it doesn't clip too harshly for the graphics. And I can, of course, redimension all the graphics on a screen. I did my little custom scroll bars in SVG. I can go up and down. I just put in some useless effects when you click on stuff so you can see little animations. And of course, you can use slow motion, resize objects. Well, it's a bit buggy, but animations are performed while I redraw and resize. So I think it's really pretty neat and really opens up a new set of avenues you can take on using WebKit. And of course, this is not limited to web content. WebKit is part of your toolkit as a macOS 10 developer. And so this type of interfaces could be directly hosted in a Cocoa app, integrated with JavaScript, hook up Objective-C callbacks in JavaScript and vice versa. And I think you have a whole brand new world of possibilities for your applications. And that pretty much wraps it up. And I will hand the mic over to George, who I'd like to thank for hosting this track. And before George comes up, I would like also to thank the Safari and WebKit teams for implementing all these cool graphics features and giving developers and web authors alike new, very great creative avenues to explore. Thanks.
Awesome. Thanks, everyone. And just to summarize detailed demonstrations of the stuff that you just saw, Antoine will be hosting this code on his website. So by the time all of this information gets posted to the WWDC ADC site, we'll have links and you'll be able to directly download the sample code of the demos that you just saw. So I want to wrap up with one little note, and we're adding this basically one more thing slides to all the content and media sessions. We want to remind everyone, what we're talking about is building AJAX applications. And when you're building a desktop AJAX application, you know, that application is going to be able to run on the iPhone. With that aspect, we want to reiterate that was what was discussed in yesterday's session about good design practices. We'll be having a rebroadcast of the iPhone developing for websites for iPhone session tomorrow in North Beach at 3:30. So for those of you that were not there, or those of you that were there and would like to take more notes on what you saw and what you heard, please, we welcome you to revisit and rewatch that session. So coming to good design practices, essentially, column layout. When you're building out your design, think grid system, think Swiss grid system, and design things so that it makes the touch sensitivity on the device and the multi-touch capabilities, I guess the functionality work better with the content that you're laying out. Size matters. You're dealing with edge and you're dealing with Wi-Fi. So when you're building out your content, you're taking that all into consideration. Please keep that in mind with the types of imagery or the types of video that you might be using within your content. And also the constructs of the resolution independence graphics that you might be laying down with CSS3. Media queries. CSS3 is extremely important. This will be able to do the dynamic resizing and dynamic layout of your website content based on your landscape or portrait views on the actual iPhone. And then lastly, optimizing for iPhone. The key things you want to remember and consider when building out this content. Remember the viewport, the height and width of landscape and portrait modes when you actually put that into your CSS queries. Remember the only tag. Using the only tag will basically allow non-iPhone or mobile web browsers to ignore that context of the actual viewport that you're assigning. Double tap when you're dealing with your content. Remember the different types of DOM events that we had mentioned in the session. Remember that when you break up your content in a grid-based layout, it makes it easier to deal and navigate in and out of that content construct. And then lastly, text size adjustments. The device will basically take advantage and deal with a lot of the logic when you're dealing with your content. But again, remember when you build out your system in a column-based sort of schematic or your grid-based layout, remember the type and the flow of the content, so you're not using a div and having it completely fill the width of the page. Break it down into, again, column view. And then lastly, the events. Dealing with the JavaScript events, we'll cover that again in the session tomorrow with the rebroadcast, but there are a select amount of events that are supported on the actual device, and get up to speed on that. And then lastly, your media. Again, edge versus Wi-Fi. Take into consideration how you're going to actually encode that media, the bit rate you're going to be dealing with it, and also your ref movies that you're going to be creating when you're dealing with switching out of HTML context into H.264 context when you're dealing with audio and video. For more information, again, go to the session tomorrow at 3:30 in North Beach. The internet WWDR contact for dealing with iPhone issues right now is Mark Malone. We've got a lot of helpful URLs here dealing with both the user agent detection, dealing with the W3C and what working group specifications around sort of future iterations on what the browser will be supporting, as well as CSS3 media queries. And then up there, right there, that's actually, is that the URL for your sample? Yes, so that URL there, you'll be able to download Antoine and Dean's sample application code. Again, this will be posted to the ADC website. For those of you, quick couple seconds if you want to copy that down. It will be posted shortly. Go there and look at a blank page. And now when you're dealing with media as it relates to the iPhone, Alan Schaefer is your WWDR contact. We've got some tutorials, and we have a ref movie maker tool that you can download in preparation for your actual content. Remember that the type of media that the device supports is a H.264 baseline profile.